Hello everybody, in this video I will show you how to solve trig equations in all four quadrants. I will start with the introduction and then in the end we will look at this example below. Now here in the first quadrant, when I give you this arm or terminal ray if you like, then there's the point P and the coordinate for the point P will be x, y. And remember, r is always positive. Then in the first quadrant, sin's ratio is y over r, and then plus y over plus r is a plus. Therefore, sin is positive in the first quadrant. When I give you cos theta, cos's ratio is plus x over plus r, which is a plus. Therefore, cos is also positive in the first quadrant. Tan theta is y over x, which is positive. Therefore, all three functions are positive in the first quadrant. Therefore, I'm going to write all there. Now, in the second quadrant, there's your terminal arm, and there's positive r, and there's your point P. Your point's coordinate will be negative x, y. Now, sin's ratio is y over r, therefore positive. That means in the second quadrant, sin is positive. Cos's ratio is minus x over r, therefore negative. Cos is negative in the second quadrant. Tan theta is y over minus x is negative. Therefore, the only function that is positive in the second quadrant is sin. So we've got all of them positive in the first quadrant, and now only sin is positive in the second quadrant. Let's investigate the third quadrant. Now, in the third quadrant, there's your terminal arm, there's your point, and the coordinate is negative x, negative y, and r is positive. Therefore, sin's ratio is minus y over r, therefore negative. Sin is negative in the third quadrant. Cos's ratio is negative x over r, therefore negative. Tan's ratio is minus y over minus x, and a minus divided by a minus is a positive. Therefore, in the third quadrant, tan is positive. Let's recap. In the first quadrant, all three are positive. In the second quadrant, sin is positive, and now in the third quadrant, tan is positive. Let's deal with the fourth quadrant. There's your terminal arm, and there's your point P with the coordinate x, negative y, and r is positive. Therefore, sin's ratio is minus y over r, which is negative. Sin in the fourth quadrant is negative. Cos's ratio is x over r, which is positive. Therefore, in the fourth quadrant, cos is positive. Tan's ratio is minus y over x, and that results in a negative. Therefore, tan is negative in the fourth quadrant. Then, let's recap. In the first quadrant, all of them are positive. In the second quadrant, sin is positive. In the third quadrant, tan is positive, and in the fourth quadrant, cos is positive. I just want to show you the relationship between the three trig graphs and the Cartesian plane. Now, first of all, on the right hand side here, the first graph is the graph of y is sin x, y is cos x, and y is tan x. Now, if you look at the first graph, this is 0 degrees. So from 0 up to 90, that is where you will find the first quadrant. Then 90 to 180, second quadrant, third quadrant, and fourth quadrant. Now I want to explain to you, using the graphs, why in the first quadrant all of the functions are positive. So if you have a look here, this is the first quadrant from 0 up to 90. And can you see the sin graph is above the x-axis, therefore positive. That's why sin is positive in the first quadrant. On the cos graph, again, although this graph is descending, it's still positive. And then on the tan graph, this one again is positive in the first quadrant. That's why all of them are positive in the first quadrant. In the second quadrant, sin is positive. And then if you go to the sin graph, you will see here, this represents the second quadrant, and sin is positive there. Although it's a descending graph there, it is still positive. And then you can see here in the second quadrant, on the cos graph, cos is negative, and the tan graph in the second quadrant is negative. Then in the third quadrant, tan is positive. So let's just go to the tan graph. There's the third quadrant from 180 up to 270, and tan is positive, cos is negative, and sin is negative. And in the fourth quadrant, there you can see sin is negative, cos is positive, and tan is negative. So maybe this will help you to understand the Cartesian plane a little bit better. Now, before I get to the actual sums that you can expect in the exam, I just need to explain something with you. The question says, determine in which quadrant the terminal arm lies in if. And then I give you two scenarios. Now, this is very important because this is how you will pinpoint in which quadrant your terminal arm lies. Now, if you look at the first sketch here, sin A bigger than 0. That translates to sin is positive. And where is sin positive? Sin is positive in the first and the second quadrant. And we have tan A bigger than 0. In other words, tan positive. Where is tan positive? In the first and the third quadrant. So now this is where you find your 2 stars. That is where your terminal arm will lie. If we go to the second one on the right here, sin B greater than 0 means where is sin positive? Sin is positive in the first and the second quadrant. And this you read as B is smaller than 360 and B is greater than 90. So that implies second, third, and fourth quadrant. And then there where you find your 2 stars, this is where your terminal arm will lie. Now the third one here on the left at the bottom, cos C greater than 0. That means where is cos positive? Cos is positive in the first and the fourth quadrant. And then this one reads as C is an element 0 up to 180. That means first and second quadrant. Therefore, your terminal arm will lie in the first quadrant. The last one, cos alpha smaller than 0 means where is cos negative? Cos is negative in the second and the third quadrant. And sin alpha smaller than 0 means sin negative. Sin is negative in the third and the fourth quadrant. Therefore, your terminal arm will lie in the third quadrant. Now, this is very important information, and we're going to use this concept now in the actual sums. If 13 cos beta is equal to 5 and sin beta smaller than 0, evaluate tan beta times sin beta. Now, this is what you want to work out. Tan beta times sin beta. And then all the other information there is what's going to guide you and help you to get to the answer. Now, we start with this 13 cos beta, and we make cos beta the subject of the formula. So therefore we will divide away the 13 and we end with cos beta is equal to 5 over 13. Then cos's ratio is x over r. So that means the x is 5 and the r is 13. And then since this is a positive, we read it as where is cos positive. Cos is positive in the first and the fourth quadrant. But now we need to pinpoint the quadrant, and this is where we go to the other little bit of information where I tell you sin beta smaller than 0. That means where is sin negative? Sin is negative in the third and the fourth quadrant. Therefore, your terminal arm will lie in the fourth quadrant. And that is important because that will imply that your y is negative. Now, to find what we have to evaluate, tan beta times sin beta, we need a value for x, r, and y. At this stage, we have a value for x and we have a value for y, but we don't have a value for we have a value for x and r, we don't have a value for y. So we will calculate the value for y using the theorem of Pythagoras. Now we substitute. In x's place we substitute 5 squared plus y squared is equal to, and in r's place 13 squared. 5 squared is 25 plus y squared is, and 13 squared is 169. Let's solve y. So the 25 will walk across and it becomes y squared is 169 minus 25 is 144. But I don't want y squared, I want y. Therefore, I will take the square root both sides. Remember, when you take the square root on the right hand side, you have to add plus or minus. Therefore, the square root of 144 is 12. So now we have y is plus or minus 12. Which one to choose? This is why we needed the quadrant, and it's the fourth quadrant, and in the fourth quadrant y is negative. Therefore, we choose y is negative 12. Now we have values for x, y, and r, and we can go to the sum. Evaluate tan beta times sin beta. Tan's ratio is y over x times sin's ratio is y over r. And now we substitute. In y's place, minus 12 over x's place 5 times y over r, negative 12 over 13. And we multiply. A minus times a minus is a plus. 12 times 12 is 144 over 5 times 13 is 65. If 2 sin theta plus root 3 is equal to 0 and cos theta is smaller than 0, evaluate tan squared theta minus 1. So this is what we want to calculate in the end. We need a value for x, y, and r. This is why this was given, the 2 sin theta plus root 3. So we will isolate the sin theta, then the plus root 3 will walk across and we will divide away the 2. And we end with sin theta is negative root 3 over 2. Sin's ratio is y over r. Now we can pinpoint the quadrant. We will say, where is sin negative? Sin is negative in the third and the fourth quadrant. But we can't work in two quadrants, so therefore we will go to this other information that was given to decide in which quadrant we will work. Cos theta is smaller than 0 means where is cos negative? Cos is negative in the second and the third quadrant. Therefore, we will work in the third quadrant. Now, we've got a value for y, we've got a value for r, and we need a value for x. How will we find that one? With the theorem of Pythagoras. x squared plus y squared is r squared. X squared is what we're looking for. In y squared's place, we substitute negative root 3 squared is equal to, and r's value is 2. Then, in the next step, we will say a negative squared is a positive, and the square root, and when we square the square root, it falls away and it becomes only 3. And on the right hand side, 2 squared is 4. Now we can solve x. The 3 will walk across. X squared is 4 minus 3. X squared is 1. We don't want x squared, we want x. So we take the square root both sides. When you take the square root, you add plus or minus. Therefore, x is plus or minus 1. Now, which x to choose? We are working in the third quadrant and x there is negative. Therefore, x is negative 1. Now we have a value for x, y, and r. We can work out what was given. Evaluate tan squared theta minus 1. Tan's ratio is y over x squared minus 1. In y's place, we substitute negative root 3 over, in x's place, negative 1. And then you will say a minus divided by a minus is a positive. Root 3 squared is just 3 over 1 minus 1. 3 minus 1 is 2. In the next video, I will discuss two-dimensional problems in trigonometry. Click on the video in the left-hand corner to take you straight to the next lesson.